Hi, my name is Jack, and this is my week 8 project on the MATLAB composite body. I like to start off with the results so you can see my geometry and what I'm working towards. So I have a three-body system. The top and the bottom are mirrored frustrums with base B and height H and top length of A. We're going to compute for the bottom surface 1 by hand, and I'll kind of go through the hand calcs first because I think they explain the project the best. So we're looking for 576 in the E1 direction, 576 in the E2, and negative 31,104 in the E3 direction for our total force on that surface. So first we start with the body and the parametrization of it. I defined this as my Cauchy stress symmetric tensor. And so I defined my S of x when I plugged in the body geometry. Then I defined that one surface. I found the area, the normal vector. So we can use that force equals the double integral of the traction times the area. First, in order to find the traction, we have to use the Cauchy stress field times the normal vector. So I just simplify it to be T1 A1 equals, and then traction, I plug in those vectors. So I end up getting that traction times area equals this equation. So I still have to do the integrals. So here's where I find the actual force. So the force is equal to the integral of what we just solved for. So I show that here. And then I solve for the integral over here. I separate it by parts and by each coordinate axes. And you'll see that I got 576, negative 31,104, just like we get with the code. Um, so then at a macroscope, we can look at each body and we'll apply the individual geometries, the x1, x2, and x3 to the defined Cauchy stress field, um, the symmetric field that we defined for this project. And it's the same for each body. You'll see it red in the top corner never changes, but we just plug in our bases for each geometry. And then this is what the MATLAB code spits back out. You'll see that surface one was the one we dealt with before. You can see 64 is the area, which is just b squared, and we solved for those forces previously. Same would go true for any of these surfaces. You could solve them the same way. Similarly, body two, same Cauchy stress, just plug in the geometry. This is what the code produces. Similarly, for the third body, we just plug in the x1, x2, x3. This one I included that the MATLAB code adds all the areas together, and the total force of this system is listed down here. The body composite. So all I have left is to show the code. Um, Command window's nice and big so you can see the numbers run. So we have our results down here. You can see the one we calculated for right up top. And then, ooh, where'd the figure go? Oops. Here's our figure. All right, thank you.